Hello everyone, myself Nithin Heraje, Assistant Professor, Department of Computer Science and Engineering, AJ Institute of Engineering and Technology, Mangaluru. Today I am going to discuss Module 3 of Computer Graphics and Visualization subject. Under that, Chapter 10, Error Detection and Correction. Here we are going to discuss is about cyclic codes, that is nothing but one of the technique to detect error in the bits or sent message. So let's see what are cyclic codes. Cyclic codes are special linear block codes with one extra property, that is in a cyclic code, if a code word is cyclically shifted, there is nothing but rotated, it might be either left shift or right shift. The result is another code word. The result is another code word. So let us look at this example over here. So uh, we have this is the code. Okay. So 11001110 is the code which is cyclically left shifted. That means the last bit in the left end will be shifted to the first bit of right end. So that's what you can look at this. So when it is shifted, you will read it as 1001110 and the shifted bit as 1. So you will find that example here, that is 1001101. Okay, so this is a cyclically left shifted code word. Okay, and the result, that is this in fact becomes another code word. Okay, got it. So under this we are going to study cyclic redundancy check, hardware implementation of uh, cyclic redundancy check. We call it nothing but CRC, okay, which is cyclic redundancy check. And then polynomials, then cyclic code analysis, advantages of cyclic codes and other cyclic codes. So let us discuss one by one. Uh, let us discuss one by one. So before that, let us go to this CRC, that is cyclic redundancy check code with the C7,4. The C7,4 nothing but you're having a combination of 7-bit code word and a 4-bit data word. So if you look at this here, you are having a 7-bit code word, wherein this is the 4-bit data word. Okay, so 4-bit data word, if we try to have the combinations, we will have 16 different combinations. Okay, and here you can see highlighted in pink color, this is the appended code word for the original data word, that is here. Okay, so what I can say here is this 3 is nothing but the 4 minus 1, 4 bits over here, that minus 1 you get it as 3. So 3 bits are appended to a 4-bit data word, and this altogether it becomes a code word. Okay, so if you look at this table, there are 16 different combinations of data word along with the code. Okay, so we'll just uh, in the previous slide we saw that one code, if it is left shifted cyclically, then you get another code word. Okay, just let me check any one of example over here. Um, Let me consider this as one code, uh, which is 0 1 0 0 1 1 1. So if we left shift this, what are we going to get? We will get 1 0 0 1 1 1 0. Okay, so 1 1 1 0, which is a left shifted code word. Let us check where we can find this. Okay, so we have this code word here. Okay, that is if one code word, that is this code word, if it is left shifted with number of bits, then we, or if it is cyclically rotated, then we get another code word. So from one code word, that is this code word, if we cyclically rotate, we are going to get another code word, that is here. Okay, so 0 1 0 0 1 1 is one code word, which when left shifted by one bit, we get it as 1 0 0 1 1 0, and that is nothing but one more code word that we find it here. All right, so I hope you are clear with what is that code word and all those things and what we are going to append. So if we are having 4 bits of data word, then we are going to append 3 more bits, that is 4 minus 1, we are going to get it as 3. So data word plus 3 bits of code word, we get it as a code word. Okay, so we'll move on to the next. So what you see here is a CRC, that is cyclic redundancy check encoder and decoder. So encoder, that is in the sender part, whatever data word you have, so you encode something and send the data to the receiver end, wherein in the receiver end you will have to decode and get back the original data. So we'll see how this CRC encoder will work first. Once we are done with that, next we'll see how CRC decoder is going to work. Okay, so if you look at this encoder, here there is a 4-bit data word that has been given, so for which we'll have to append n minus 1 bits. So this is that 4 minus 1, 3 bits that has been appended. All these data word and the appended 3 bits is passed on to the generator. The generator is nothing but which will generate a remainder, and you will be taking a divisor. Okay, that is a 4-bit divisor here, which is common to both the encoder and the decoder. So you'll have a divisor here, then this generator is going to find the remainder. Okay, we'll see in the next slides how we calculate these things, that is how the generator is going to generate the remainder with the given data word and the divisor. Okay, so the given data word we are going to append n minus 1 bits. So if 4 is the number of bits of data word, then So the data word is 4 bits, and then we are going to append 3 bits here, and we are going to pass to the generator, where generator will generate a 3-bit reminder here. Okay, so this 3-bit reminder is augmented or appended with the data word. Okay, so A3, A2, A1, A0 is the data word for which uh, it is going to append the remainder, that is the 3-bit remainder. Now this 3-bit remainder uh, will be sent in the unreliable transmission. So unreliable in the sense, again, it is a not a reliable transmission where your data word might be changed, where your sent message might be altered. Okay, so it receives in the receiver end like this, that is B3, B2, uh, B1, B0, Q2, Q1, Q0, since it is not sure if the received message is same as that of the sent message. So in order to check if the received message is same as that of the sent message, the received code word is sent to the checker. This checker, again, it will use the same common divisor, 4-bit divisor, and it will perform some operations, that is the division operation, and then it gets you the syndrome, a 3-bit syndrome. A 3-bit syndrome is nothing but it is a remainder, and this syndrome is passed to the decision logic to decide if the received uh, data word has to be accepted or rejected. So how it is accepted? If the syndrome is having the value as the 0, then the decision logic will accept the data word. If the syndrome is a non-zero, then the decision logic will discard the data word. Okay, so this is how it works in the decoder. And now I hope you are clear what are the different operations uh, that takes place in the sender part, and what are the different operations that take place in the receiver part. So now let's go further, and we will check this example. So this is what it is going to happen in the generator. So the generator will perform the division. Okay, so generator will perform the division. You are having the data word as 1001. Okay, you are having the data word as 1001. So uh, here what you have to do is you will have to augment 3 bits. Why it is 3 bits? If the data word is 4, then n minus 1 is 3 bits. So you will have to augment the 3 bits to the data word, and you will be given with the divisor. Here the divisor is 1011. Okay, now we'll start the division process. We'll see how this division process will work. uh, we have this 1001, a 4-bit code word. If you check here in the leftmost bit, you are having it as 1. So if the leftmost bit is 1, then you'll have to take the quotient as 1. So you'll have this here 1011. For this, you will now have to perform the XOR operation uh, by eliminating the leftmost bit. Okay, so what is the truth table for XOR operation? We know that if it is the bits are 0 0 or 1 1, the result will be 0 for XOR, and if it is 1 0 or 0 1, the result will be 1 for the XOR operation. Okay, so now we'll see this uh, here you have this 1 1, so XOR of 1 1 is 0. Next we have 0 1, XOR is 1, 0 0 is 1, and this leftmost bit is eliminated. Okay, so we'll have 3 bits now. So at this point we'll have to take 1 bit from the 3 bits that has been augmented. So I'll be taking the first bit here. So now we have 4 bits as 0 1 0 0. Now again repeat the same process. So the leftmost bit is 0. If the leftmost bit is 0, then what has to be done? Uh, if the leftmost bit is 0, then you will have to take the quotient as 0. So you will have uh, 0 0 0 0 here. Now here again you will have to eliminate the leftmost bit, then perform the XOR operation for three bits. So 0 0 is 0, 0 0 is 0, 1 0 is 1. Okay, so you'll have these 3 bits. Now again append the second bit from the augmented 3 bits. So your 4 bits will be 1 0 0 0. Okay, now again the leftmost bit is 1, so you'll be taking the quotient as 1, so you'll have 1 0 1 1. Now again apply the XOR operation. So 0 1 is 1, 0 1 is 1, 0 0 is 0, and you're going to discard the leftmost bit. Okay, so you'll have these 3 bits. Now again get the third bit. So you'll have 0 1 1, 0 is 4 bits. So check with the leftmost, it is 0. So again your quotient becomes 0, and you'll have 0 0 0 0. Then perform XOR. 0 0 is 0, 1 0 is 1, 1 0 is 1, and then eliminate this leftmost bit. So we are done with all these 3 bits. So we'll stop at this point, and these 3 bits are called as remainder. They are nothing but remainders. So remainder is 1 1 0. Okay, which is a code word. Okay, so that has been added here. So 1 0 0 1, for this particular data word, the code word is 1 1 0. Okay, so sorry, the remainder is 1 1 0, and you get this whole thing as the code word. We can just verify this. Just remember this 1 0 0 1 for the data word 1 0 0 1. We'll see what is the remainder. Okay, in this given table 1 0 0 1, we have the data word as 1 0 0 1. So for 1 0 0 1, the remainder is 1 1 0, and this becomes the code word. Okay, so just a verification. So for the 1001 data word, you are having 110 as the remainder, and this whole thing it is the code word. Okay, so this is the process that takes place in the generator of the encoder part in the sender side. Next we'll see what happens in the checker process, that is in the receiver's end, that is in the decode part. So as you know from the previous, we get this code word 1001 and 110, which is the remainder. Okay, that has been appended to the code word, data word 1001. So this 7-bit code word we are going to have. So if you look at this, we have this 10011110 as the code word that is received from the sender's end. And if you look at this divisor is the same as that of which has been there for the sender part also. So again, the same process will continue. Just look into this leftmost bit. Since the leftmost bit is 1, we'll take the quotient as 1. We'll have 1011. Perform XOR operation. So 11 is 0, 01 is 1, and 00 is 0. Just to discard this leftmost part. Okay. Then append 1 bit from the 3-bit remainders. Okay, so that is the first bit is 1, so we'll have 4 bit as 0 1 0 1. Now again continue the process. The leftmost bit you are having it as 0, so the quotient will make it as 0, so we'll get this as 0 0 0 0. Again perform the XOR operation. So 1 0 is 1, 0 0 is 0, 1 0 is 1, and we'll have to just eliminate or discard the leftmost bit. So the 3 bits are 1 0 1. Now append the second bit from this. So 1 will be here. Your 4-bit code will be 1 0 1 1. Again continue the same process. You will have 1 in the leftmost, so the quotient becomes 1. So get it as 1 0 1 1. Again perform XOR operation between these two. So 1 1 is 0, 1 1 is 0, 0 0 is 0. Eliminate this leftmost part. Okay, eliminate the leftmost part, and then here just append the third bit, so we'll get a 0 0 0 0. Okay, now again the leftmost is 0, so again your quotient is 0, and you get it as 0 0 0 0. XOR these again, so 0 0 you get it as 0, 0 0 you get it as 0, 0 0 you get it as 0, and discard this leftmost part. So you get the syndrome as 0. So as previously said, if the syndrome is 0, then we are going to accept the data word which is 1001. Okay, if the syndrome is not 0, then we are not going to accept the data word. So this is one code word that we received. Now let's see the same code word. We are just going to change this 1 bit of data word. So here the 4th bit here in the data word is you have it as 1, and here we have made it as 0. Same operation continues here also. Same operation continues here also. And if you look at in the end, in the remainder part, you get it as 0 1 1, which we call it as a syndrome, which is a non-zero. Since it is non-zero, we will discard the data word. So we are going to discard the data word. All right. So I hope you have understood this part. That is the CRC, cyclic redundancy check. Uh, in that we have looked into encoder and decoder part. I hope I have made it clear. Okay. So on the next part, we are going to study about CRC polynomials. Okay. Uh, Thanks for watching. I hope you understood this. Thank you.